Greetings and welcome to Train Signal. You're watching Call Admission Control with Microsoft LYNC Server 2013. In this video presentation, you're going to be introduced to a bandwidth management feature built right into LYNC Server 2013. It's called Call Admission Control. Call Admission Control allows a LYNC administrator the ability to apply limits on the amount of bandwidth that can be used across our wavelengths for both real-time audio and real-time video. We can apply these limits on a per session basis and on a total aggregate basis. With our unified communications platform, we have a lot of different types of data that will be going across our network, including audio, video, and application or desktop sharing. If we look at the communication within a LAN-based environment, we're typically not as concerned within the LAN because within a LAN we usually have the bandwidth and we don't need to put limitations on our clients. It's when we look at the communication going from one site to another site across our wavelengths that we typically have to apply policies to restrict the amount of bandwidth that your clients will be able to use. If the unified communication clients overconsume a network and the network becomes congested, you end up getting a poor quality of experience for all of the users going across that link. It's kind of like being stuck in commuter traffic when there's too many cars on the highway. For conventional data transfer, we can use a lot of different techniques on the network such as buffering, queuing, and even packet dropping to be able to recover from congestion. Unfortunately for your real-time communication, it's a lot more sensitive to latency and packet loss, such as with real-time audio and real-time video. Call Admission Control is used exclusively for real-time audio and real-time video. It doesn't affect other types of data transfer. The way that the enforcement works for Call Admission Control is that it's the client that is being called that will enforce the policies and determine whether a call can go through or not as is. So if you were to place a call to me, my client-side software would check with the network policy services to verify if it's okay to accept the call or not. As an end user, I wouldn't even see a notification that there was an incoming call until the policy was verified, and then I would get my pop-up toast message or my phone would ring. Call Admission Control came out back with Microsoft LYNC Server 2010, so it doesn't get enforced by clients prior to LYNC 2010. So you would have to have a client like your LYNC 2010 client or the LYNC 2013 client, the LYNC 2010 attendant, or possibly the LYNC Phone Edition. If our network links are being overconsumed based upon the policies that we've defined with Call Admission Control, the call can get routed over to voicemail, or it can get routed across another media, like for example out through your PSTN lines or out through the edge services. So if we have maxed out the amount of bandwidth allocated through a policy on one of our WAN links, when you go to place a call to somebody else, the call could get routed to voicemail, or instead of going across the WAN link, the call could also get rerouted either through your edge servers out across the internet or across your PSTN lines in the case of clients that are enterprise voice enabled. In order to use Call Admission Control in our LYNC 2013 environment, we don't have to purchase any additional hardware. There's no hardware required, but we do have to configure it through our topology builder and also coming in either through our control panel or through the LYNC Server Management shell. The enforcement of Call Admission Control policies is going to be based upon the endpoint locations of your clients. That's their IP addresses. Part of the process of setting up Call Admission Control is to define Microsoft LYNC sites, which are defined by IP subnets. So as a client tries to establish a real-time audio or video session with another client, the client that is being called will contact the network policy services and check to see if it's okay to accept the call or not. Well, the network policy services will also have information provided to it from the client in regards to the IP addressing, so it knows where the client is making the call and the client receiving the call. You also want to be aware that Call Admission Control can also calculate links from a client to a mediation server and from a mediation server over to a gateway. Call Admission Control policies are only applicable to real-time communications. That's real-time audio and real-time video. As we attempt to place a call across a WAN link, if there is not enough bandwidth available, or if we have maxed out the amount of bandwidth that we've allocated inside of our policies getting enforced by Call Admission Control, the order of precedence for rerouting the calls would be to reroute the call across the internet. Second, we would look for a PSTN connection, and third, we would look for voicemail. Both audio and video calls can get rerouted out through your edge servers. So if I have two separate locations that both have an edge server, your calls could get rerouted out across the internet, both audio and video. Now your PSTN is only used for audio. and it would require that your clients are enterprise voice enabled. So if the WAN link didn't have enough bandwidth available, we could route the call out through your PSTN connection and then route the call back in the PSTN connection at the other side. The third choice would be to route the call to voicemail. The call admission control policies that we define are going to be enforced by the bandwidth policy service that gets installed with every front-end pull in our LYNC environment. Once we define the call admission control settings, they get automatically propagated amongst all the LYNC server front-end servers within the network. In order to monitor call admission control with LYNC Server 2013, there's a couple of different tools that we can use. We can use the built-in monitoring services to capture information to the call detail records database. We can also use logging. The call detail recordings captures information about calls that are rerouted to the PSTN or voicemail. We also have a couple of CSV files or log files that we can inspect. There's a check failures log file and a LYNC utilization log. The bandwidth policy service check failures log file captures information when bandwidth requests are being denied, whereas the LYNC utilization log file captures a snapshot of your network topology and your WAN link bandwidth utilization at a point in time. So as you deploy call admission control, you're probably going to spend a little bit of time monitoring these log files to make sure that things are working the way that they're supposed to and that your bandwidth policies are fine-tuned. With call admission control policies, we've already established that the enforcement happens on the client that is being called. And it's also a requirement that that client would have to be a LYNC 2010 client or newer, meaning LYNC 2010 or LYNC 2013, the LYNC 2010 attendant or LYNC phone edition. Clients prior to LYNC 2010 did not have this feature support, so they don't know how to enforce policies. In fact, they don't know what a policy is. The point that I do want to add to this is that the client that is initiating the call, not the client being called, but the client that's doing the calling. It doesn't matter if this client is a legacy client or not, because that's not where the policy is enforced. The requirement is on the client that's being called. Let's take a look at some of the steps that are involved with setting up call admission control. Let's take a look at a high-level overview of the process involved with configuring call admission control. Keep in mind that we're going to see how to do this in a demonstration. For the network bandwidth policy services to be able to enforce policies for bandwidth utilization across our WAN links, we have several things that we have to define inside of our topology. Let's take a look. While defining your settings for call admission control, we have to define networking regions. A networking region is like a networking hub or a backbone for networking connectivity. Your regions are typically interconnected by a major pipeline. Whether you're creating a region inside of the control panel or through the LYNC server management shell with the new-cs network region commandlet, in either case the region will have to be provided with a name and you'll have to associate that region with a LYNC central site. Microsoft LYNC Server 2013 uses regions for call admission control for E911 and media bypass. We also have to define network bandwidth policy profiles. A network bandwidth policy profile is a configuration that defines how much bandwidth we're going to allocate for real-time audio and real-time video on both an aggregate basis and on a per session basis. So the network bandwidth policy profile defines your limits for bandwidth usage. And when we attach a site to a region, we can apply a network bandwidth policy profile on that association. And we can also apply a network bandwidth policy profile on the inter-region connectivity called an inter-region link. We'll see how to set these up in just a moment. With Microsoft LYNC Server, we define LYNC sites inside of our topology builder. And those are either central sites or branch sites. Well, for call admission control, for E911 and media bypass deployments, we have to define network sites inside of our control panel or through the LYNC server management shell. When we define a network site, we have to associate it with a networking region, and we can define if we want to apply a network bandwidth policy profile on that attachment. So in essence, when you attach a site to the region, you can define if there is a bandwidth limitation for the transfer or communication with other clients within that region, from one site to another site. Although we already have sites defined inside of Active Directory sites and services, we still have to define our networking sites inside of Microsoft LYNC Server. They're both very similar in nature in that you have to define the name of the site, and you also have to define your IP subnets that comprise the sites. But they're not related, so Microsoft LYNC will not inherit the sites that you already have inside of AD. In order for the Microsoft LYNC server and the policy services to enforce call admission control, it has to understand where your clients are based upon sites and the subnets that they're located in. So we have to define subnets and associate them with the LYNC sites. If you have a subnet that you want to be managed by call admission control, it has to be defined and associated with a site. So the Microsoft LYNC server has the ability to apply bandwidth policies on a connection from a site to a region, and also on connections from one region to another. But the product has to understand where your client is located based upon your IP address, and this is done by creating these subnet objects that we associate with our sites. In order for Microsoft LYNC server to be able to enforce call admission control from one region to another region, we have to define inter-region links. An inter-region link is a Microsoft LYNC representation of a major pipeline within your network environment. When you define an inter-region link, you can define if you want to apply a bandwidth policy profile to that link. So if I have a link that connects Scottsdale over to Phoenix, I can define if I want to apply a network bandwidth policy profile on that link that will limit the amount of bandwidth that can be allocated for real-time audio and real-time video. We've just seen that in order to define the connectivity from one region to another, we have to define something called an inter-region link. But inside of Microsoft LYNC server, we also have to define something called an inter-region route. And an inter-region route tells the Microsoft LYNC server that if real-time audio or video traffic has to go from region 1 to region number 2, the traffic will have to go across these inter-region links. It's a way of telling the LYNC server that if traffic has to go from this region to that region, the traffic will have to go across these network pipelines that could have network bandwidth policy profiles associated with them. For situations where we have a direct connection from one site to another site, we can also define inter-site policies. A network inter-site policy allows you to tell the LYNC server that traffic can go from site 1 to site 2 directly using this specific policy settings. We also have to remember that in order for call admission control to be enforced within the environment, not only do we have to enable it inside of our topology builder for our sites, we also have to enable call admission control as a global setting inside of our control panel or through the command line. Before we go through our demonstration on setting up call admission control, let's take a quick look at a checklist of actions that we want to perform, and then we'll see an applicability scenario for how we're going to apply call admission control at Carverock Fitness. When you're deploying call admission control throughout your organization, we have a global toggle switch that enables call admission control for the organization. It's either on or it's off. This can be applied through the control panel or through the LYNC server management shell. To deploy the network policy services throughout your organization, you have to enable call admission control on your sites inside of the topology builder. You also want to make sure that you've accounted for all of your subnets within your organization. So for any subnet that is considered a managed subnet within your environment, you want to make sure that you define a subnet object inside of Microsoft LYNC and you associate that with a network site. If your Microsoft LYNC client is using an IP address that has not been accounted for on a subnet associated with a site, the LYNC server will not know how to account for the client when it's trying to apply call admission control policies. In this diagram, you can see a high-level overview of how we're going to set up call admission control at Carverock Fitness. The first thing that you should notice in the diagram is that I have two major regions. I've got a region called Phoenix, and I also have a region called Scottsdale. We have high-speed redundant links that connect Phoenix and Scottsdale together, and the high-speed link is represented by an inter-regional link, as we see here by that double-ended black arrow. When you define a region inside of your control panel or through the LYNC server management shell, you'll have to associate the region with a Microsoft LYNC central site. So my Phoenix region will be associated with a site called Phoenix, and my Scottsdale region will be associated with the site called Scottsdale. A region represents a hub for networking, and it's typically comprised of sites. So as you can see in the diagram, I have a bunch of sites around Scottsdale, and I also have a bunch of networking sites around Phoenix. The sites that you're seeing in the diagram, these are not Microsoft LYNC sites, they're Microsoft LYNC networking sites. Regular LYNC sites, such as central sites or branch sites, those are defined inside of your topology builder. Well, these sites are defined either in the control panel or through your LYNC server management shell, and they represent network locations such as branch offices or locations for our company. Here you can see that I have a Phoenix region and it's comprised of 5 networking sites, Laveen, Guadalupe, Surprise, Peoria, and Glendale. When you associate a site with a region, you can define if you want to apply a network bandwidth policy profile on that link. So when we create a networking site inside of our control panel, you're going to see that you'll have to associate your site with a region. So for example here, I've got Laveen, and I've associated Laveen with my region called Phoenix. And we'll also see inside of the graphical user interface or through the command line that you can define if you want to apply a network bandwidth policy profile on that link. And a network bandwidth policy profile applies a limit. So in this case, I have an audio limit of 2000 kbps, a per session limit of 200, a video aggregate limit of 1400 kbps, and a video session limit of 700. So if a client in Laveen tried to establish a real-time audio or video session with a client in one of the other sites like Glendale, Peoria, or Surprise, these bandwidth limitations would get enforced by the call admission control. You can also see that I've set up an inter-site policy between Laveen and Guadalupe. So if traffic has to go from Laveen over to Guadalupe, the call admission control is going to be using a different policy as opposed to the policy that's connecting Laveen into the region. Once you have created your sites and you've associated them with your regions, you have to define subnet objects and associate them with the sites. A networking site is defined by IP subnets, just like inside of Active Directory's sites and services. But keep in mind, the sites that you have defined already in Active Directory sites and services, they're not going to apply here. Microsoft LYNC uses its own configuration settings. It does not inherit the sites that you have inside of AD. If a client is on a subnet that's not defined inside of your topology, call admission control will not know how to apply limits to that client, because the client's on a non-defined subnet or a non-managed subnet as we call it. One of the steps that we also have to take as we're going through the configuration of call admission control is creating or defining network bandwidth policy profiles. Network bandwidth policy profiles define the amount of bandwidth that can be used for real-time audio or video either on a per session or on an aggregate basis. The network bandwidth policy profiles can be attached or applied when a site is attached to a region or when two regions are interconnected through an interregional link. So as you'll notice in the diagram, as I've associated Laveen, the site, I've applied a policy to it. And as I've created this interregion link, which represents a network pipeline in between Scottsdale and Phoenix, I've also applied a limit over here as well. When you have network pipelines that connect your regions together, those are represented to Microsoft LYNC Server as a regional link. Your interregion links are software objects used by Microsoft LYNC Server that can be used to represent a connection that connects one region over to another. And we have the ability to apply network bandwidth policy profiles to these connections. We also have to tell the Microsoft LYNC environment that if traffic has to go from Region 1 Phoenix over to Region 2 Scottsdale, that the traffic will have to go across the interregion link. So you have to define the regional routes, and a regional route is defined by Region 1 and Region 2, and the interregion links that the traffic has to go across to go from Region 1 over to Region 2, or vice versa. In this case, I have a region called Phoenix and a region called Scottsdale. And for traffic to go from Phoenix over to Scottsdale, the traffic would have to go across this interregion link, whatever I happen to call it. If you have any sites that have a direct connection over to another site, and you want to define an inter-site policy between those two sites, you have to do this through the command line interface of the LYNC Server Management Shell. You'll notice inside of the graphical user interface of the control panel that there's no way to do this from the control panel. So for my traffic going from Laveen over to Guadalupe, I'm going to have to set up an inter-site policy manually through the command line. Let's take a look at setting up call admission control, both through the control panel and through our LYNC Server Management Shell. In this demonstration, we're going to see how to set up call admission control. So to start off the demonstration, we're going to open up our topology builder. So here I'm connected over to my Microsoft LYNC server. And we're going to launch the topology builder and download our topology from the existing deployment. We'll click on OK. Here we're going to define the name that we're going to use for our topology file. I'm calling mine CACK configuration, call admission control config. We'll click on Save. Inside of the topology builder, we're going to expand our directory, and here you can see that I have my two central sites, one called Scottsdale and one called Phoenix. Now, as you go through the process of defining your sites, what you would typically do is go through the properties of your sites. So here we're going to click on Edit Properties. And as you can see, for each of these sites, you would make sure that you enable call admission control. So here mine is enabled. So you choose Enable Call Admission Control, and then you choose the front-end pool to run the call admission control, which is your network policy services for bandwidth management. Here I'm going to click on OK. And we're going to close out of here because we're already configured. The next step, let's take a look at my administrative tools, and we'll go over here to my services on my Microsoft LYNC front-end server. As I open up my services, you can see that I have my LYNC server bandwidth policy service, couple of services, my authentication and core, and they're both started up and running. Let's close out of there. The next thing that I want to do is go into the control panel and take a look at the configuration process. So here we'll go to Microsoft LYNC Server 2013 and we'll launch the control panel. Once again, we're getting prompted for our credentials, and I am going to log in as administrator. From within the control panel, we're going to go down to our network configuration, and you can see that I have my global settings, and this is where you enable call admission control. Now keep in mind that I'm not configured yet, so this is where you would enable it for your environment, and that is a global setting across the environment. You'll notice that the interface has no configurable options for the site-wide level. As we go through the process of defining call admission control, we have to define several different configuration settings for bandwidth policies, regions, sites, subnets, regional links, and regional routes. Well, let's start off with the network bandwidth policy profiles. When you click on the tab for bandwidth policies, this is where you can see the network bandwidth policy profiles that can be attached to your sites when they're associated with regions, or when we set up an inter-region link. You can see that I've already created a couple of them for the demonstration purposes. If you remember, in our environment, we have a connection from Levine over to the region called Phoenix. And for the connection from Levine over to Phoenix, I've defined that I want to have a connection with bandwidth policy limits with an audio limit of 2000 kbps and an audio session limit of 200, a video limit of 1400, and a video session limit of 700. I've called this Levine to Phoenix policy. Now, this policy itself isn't doing anything right now. I have to attach it for the site connection over to the region, and we'll see how to do that in just one moment. Let's create another bandwidth policy for my Guadalupe site. Here we're going to click on New, and then we give it a name. This is a 20 megabit link. We'll just call this 20 MB. We define the audio limit for Guadalupe, which is 4000 kbps. My per session limit is 200. We have a video limit that's going to be defined for 2800. And then I have my video session limit, which is going to be 700. So I have the video limit here, which is the aggregate total, and then I've got the per session limit for each instance. We're going to click on OK. You can see that that's how you go about creating your network bandwidth policy profiles. The next step, we go over here and we define our regions. Now, in our diagram, we have two regions. We have a Phoenix region and we also have a Scottsdale region. But for this demonstration, let's go in and create a region for Scottsdale. We're going to click on New. We'll type in the name of the region. And as you remember, when you're creating a region, you have to associate it with a Microsoft LYNC central site. I'm going to associate this one with Scottsdale. You can also see that we can enable audio and video to be able to take an alternate path. If we're trying to establish an audio or a video call, and that call is not able to be placed because of bandwidth management restrictions, the calls could get rerouted across an alternate path, which would be out onto the internet through our edge services. Let's click on Commit. The next thing that we have to do is define our sites. If you remember, regions are associated with LYNC central sites, but a region is defined by the networking sites that define it. So here when I click on Sites, I would click on New, define the name of my site like Levine. I specify the region that it is associated with. So Levine is associated with Phoenix. And then down below you can see that this is where I define if I want to apply a bandwidth policy. Then over here I've got that 10 megabit link for LYNC. We can define the location policy for E911. And then at the bottom of the console you can see that I currently do not have any subnets defined, but I have to define which subnets comprise that networking location. So once again we're going to click on Commit. Let's create another site for Guadalupe. We'll click on New. We'll define the region that it's associated with, Phoenix. And then I've got my bandwidth policy profile here, which is going to be the 20 megabit. If you have any site locations that do not have bandwidth restrictions, so for example in our Phoenix location, Surprise, Peoria, and Glendale, they didn't have any restrictions, so they have high-speed connectivity between them or amongst them. So when you're defining a site such as Glendale, you click on New. I provide the name of the site. I define the region that it's associated with, Phoenix, but down below where it says bandwidth policy, I don't have to define one. I'll click on OK. As you're defining your sites, you have to define the subnets that comprise the site. As an example of this, we'll click on Subnet and then click on New. I'm going to define my subnet ID 10.0.10.0. The number of bits that I'm using in my subnet mask are 24. Keep in mind that you cannot use dotted decimal format. I specify the site that this subnet is going to be associated with, which will be LYNC, and then you can provide a description, which is optional. Let's create one more subnet ID, and this is going to be the 10.0.20 subnet, which is also using 24 bits in the subnet mask, and that is going to be associated with my site over in Guadalupe. Once again, you want to make sure that you account for all of your subnets where you're going to have clients that you want to be managed by Microsoft LYNC and call admission control. In order to create a link, which is a representation of your network connection between two regions, we define this object here called a regional link. In our case, we have a regional link that connects Phoenix over to Scottsdale. So let's click on New. We'll give it a name. I've called mine Phoenix to Scottsdale RL for regional link. I have to define region number 1, which is Phoenix, region number 2, which is Scottsdale, and then down at the bottom of the console you can see where I can define a bandwidth policy on that link. So as I define a regional link, I'm telling the Microsoft LYNC server that I have a network connection that connects region 1 over to region 2, and this allows me to define if I want to apply a network bandwidth policy profile to that link. Here we're going to click on Commit. So now as I define my regional routes from one region to another, I'll be able to tell the LYNC server and call admission control that traffic will have to go across that link. So here we'll go to the regional route, click on New, and we'll call this Phoenix to Scottsdale. RR for regional route. We'll put in region 1, Phoenix, regional 2 is going to be Scottsdale, and then I have my network region links. So I'm telling the product that for traffic to go from region 1 to region 2, it's going to have to go across this regional link, which, as you remember, has a network bandwidth policy profile associated with it. We'll click on OK. And then we'll commit the changes. Let's take a quick look at a couple of examples of command line. Keep in mind that anything that I've performed here inside of the control panel, I can perform coming into the command line console as well with the LYNC Server Management Shell. Let's open up the LYNC Server Management Shell and take a look. All programs, Microsoft LYNC Server 2013, and here we have the LYNC Server Management Shell. In the first example of a commandlet, I'd like to create a region over in Scottsdale. If I wanted to create a region using the command line, this is the syntax that I would use to accomplish this. New-CS network region. I'm going to create a new region with the identity called Scottsdale. I'm going to associate it with a central site called Scottsdale, and I'm providing a description, Scottsdale Corporate Region. When I hit enter, I should see the identity of my site and information, which this looks like it was successful. Let's clear our screen. Here's an example of another commandlet that can be used for creating your network bandwidth policy profiles. Here you can see an example, new-CS network bandwidth policy profile. I'm creating a brand new network bandwidth policy profile, and the identity for this is going to be called 5 megabit link. I provided a description, bandwidth profile for 5 megabit links. I've defined the audio bandwidth limit and the audio per session limit. I've got a video bandwidth limit total aggregate of 1400 kbps and a per session limit of 700. When I hit enter, I should see the results of this. And if I take a look inside of my control panel, we'll do a refresh. You can see that it now pops up. And I've got my limit set. Let's clear our screen. In the next example, we're going to see how to create a site. In this example, I'm going to create a brand new site called Mesa. So let's take a look at the example of my command line. You'll notice in the commandlet that I have the new-CS network site. I'm going to create a brand new site, and the network site ID is called Mesa. I've provided a description, Mesa branch site, and I'm associating the site with the network region ID called Scottsdale. I'm also applying the bandwidth policy profile that we just created, called 5 megabit link. Let's hit enter. And there you can see that I just created a brand new site called Mesa, attached to the region called Scottsdale with a 5 megabit link bandwidth policy profile attached to it or associated with it. Let's close out of the shell. Keep in mind that we do have other commandlets that can be used for defining regional links, regional routes, and also for enabling or disabling the global settings for call admission control. Well, I hope you've enjoyed the presentation, and we'll see you in the next video.